Hello my friends, congratulations again for completing part 1 data preprocessing. You are now ready to build machine learning models, and the first models that we're going to build together are regression models. So welcome to part 2 on regression. This is the branch of machine learning that aims to predict some continuous real numbers, like for example a salary or a temperature or any kind of continuous numerical value. And together we will build the best models to make these predictions. And so now, first of all, let's make sure we're all on the same page. This is the whole machine learning A to Z folder containing all the codes in Python and R and the datasets. I gave you the link of this folder right before this tutorial, in the article, to make sure to connect to this folder, and also make sure to download the whole folder in order to get the datasets, because we will have indeed to import them whenever we build a machine learning model. All right? And so now, since we're all on the same page, let's start our new journey within regression. Part 2, regression, there we go. There are several sections inside, each section corresponding to a different regression model. We're going to start with simple linear regression, which is the simplest machine learning model you could ever build. And so it's good that we start with this, because indeed with this one we will only have one independent variable, one feature, and of course one continuous real value to predict. Then we will move on to multiple linear regression, which is based on the same equation than simple linear regression, only this time we will have several features instead of one. Then we will move on to polynomial regression, which will allow us to tackle some nonlinear datasets, datasets with nonlinear correlations, as opposed to the two previous models, simple linear regression and multiple linear regression, which can provide some amazing and accurate predictions for linear datasets, datasets with linear correlations. Then, after polynomial regression, we will move on to support vector regression, which is another kind of nonlinear model that can make some accurate predictions for nonlinear datasets with nonlinear correlations. And then finally, we will move on to decision tree regression and random forest regression, which can provide an alternative to predict an outcome for nonlinear datasets. So you'll have many options, After this part 2, you will have basically a toolkit of several regression models. And so whenever you end up with a new dataset where you have to predict a real continuous outcome, well, you can just try all of them and select in the end the one that has the best accuracy. And thanks to the code templates that will result from each of these sections, you will get very clear code templates that you can adapt to your own datasets, so that you can try these models on your own datasets in a flashlight quickly and efficiently, so that you can select the best one, giving you the best accuracy. And so now in this first section in regression, we're going to start with simple linear regression, of course. So there we go. Make sure to go inside this folder. We're going to start with Python. So let's go inside this Python folder, and you will find inside two files. First, the dataset salary-data.csv, and of course our Python implementation, which has the IPython notebook format, which I remind you can run on either Google Colab or Jupyter Notebook. And of course we're going to implement this model together on Google Colab. But first, let me explain the dataset and the problem that we're going to solve with simple linear regression. And to do this, I'm going to open our dataset here and explain what this is about. Alright, so first, I want to reassure you that indeed this is a very simple dataset, with only 30 observations. And of course, in real life, the datasets are more complex, but I want to start working on a simple dataset so that we can really focus on how to build the model itself, because if we had a complex dataset, we would lose a bit our focus on the model, and I really want us to focus on the model. So let me describe the dataset. It is a dataset containing, as you can see, 30 observations and 2 columns, with of course one feature. This is the feature years of experience, and the dependent variable which we want to predict, which is the salary. So let's say that this dataset belongs to a company that gathered data of some of their employees, collecting for each of them their years of experience and their salary. So you see, each row of the dataset here corresponds to different employees, corresponds to one employee of the company. And for each employee of this company, we have indeed the number of years of experience in the company and their salary, okay? And so the goal, very simply, is to build a simple linear regression model that will be trained to understand the correlations between the number of years of experience and the salary, so that it can predict for a new employee, having a new number of years of experience, well, the corresponding salary or the salary that this person should get. So you see, that's a very easy problem, but at least you'll know how to build a simple linear regression model and perfectly master it in all the detail. And then I want to say something very important. Remember that we're going to build each time some code templates which you can adapt to your own dataset, so that when you want to use the code template on your own dataset, you will only have one thing to change, which will be the name of your data. I will always make sure to make the code templates as much generic as we can, so that you only have one or two things to change when you want to deploy them on your datasets.